I like to move it, move it. I like to move it, move it. I like to move it.
Today we're talking about traditionally what's called one-dimensional kinematics. Is a fancy word. Linear motion is the easier way to define it. Notice what's in the word linear. The word what? Line. So one-dimensional kinematics is a study of things that move in a straight line. Sprinters running, sports cars taking off from the starting line. This is an awesome picture here. We're going to look at this later on. A very famous professor at MIT, he's actually the guy who invented the strobe light, took this photo. It's a rifle shooting the king of diamonds in half. And this is one of the first photos where we prove that bullets can go faster than the speed of sound because it forms a supersonic shock wave, and you can see it carving through the card there. Today what we want to do is introduce the basic ideas of linear motion. What do you suppose the word kinematics means? It's a fancy word. Kine is from the Greek, and I want to take a guess what kinematics means? Kine is the Greek root for motion. So that's just kind of a little bit of vocabulary there. So if you want to go into sports medicine or coaching or whatever, you'll usually be a kinesiology major, etc. for sports medicine. So first big idea is we need to find the idea that motion is relative. Like, what does that mean? All that means is you have to define your frame of reference. And basically what we're trying to pick is what's your origin? Where do your x and y axes lie? So a simple example is the surface of the Earth versus the center of the Earth. And I know this sounds kind of weird, but let's just pick something simple here. So here we got someone's comp book here, very exciting. And I'm just going to put it right here on the lab table. Very exciting. Are you excited? That's okay. Quick question, is that lab notebook, is it moving? I'm just going to stand it up right here. Is it moving? Woo, very exciting. Yeah, if you ask most people, they'd be like, what's wrong with you? Like, of course it's not moving. It's just sitting there. Like, what are you smoking, right? It's just sitting there. Are you crazy? So that's correct. That relative to you and me, its motion is like 0. It's going 0 miles per hour. If we want to be all metric, it's 0 meters per second. Now, suppose we had nothing better to do but to sit here all period and stare at that notebook. And in fact, not only do that all period, we stay here all day. Okay, we just stay here all day, and then we stay here all night, and then we stay here till tomorrow morning because we have nothing better to do. So relative to you and me, is that notebook going to move? Probably not, unless you're like, ooh, that's bad. Okay, just lay off, come talk to me, I'll get you some professional help. There you go, just kidding, just trying to keep you awake. There you go, just trying to keep you guys awake. But here's what happens. What happens once every 24 hours? Anybody know? Something weird happens. That's correct, that once every 24 hours, that notebook will go around the center of the Earth. You see that? So you know what's crazy? In order to go around the Earth in 24 hours, what do you think? You have to go fast or like crazy fast? Anybody ever fly like overseas, really far away? Actually, you're flying really far away, yeah? Actually figure out how fast that notebook is going around the center of the Earth there. And what's crazy is, actually you can figure out, how do you figure out the distance around a circle? It's like a little bit of geometry, right? Distance around a circle, what's that called? Starts with a C, something, a reference, circumference. There we go. You have to get 2 pi r, the radius of the Earth. You can look that up online. And then what's the time? The time is just hours in a day. 24, right? To get miles per hour. So what's insane is that notebook is like going faster than the speed of... Let's say it otherwise, the motion is always relative to something. And normally, since we live on, what, the center of the Earth? Where do we live? On the what? Surface of the Earth. We're assuming that's our frame of reference. Normally we don't think so abstract, like the Earth is going around the sun, we're going around the center of the Earth, the solar system's going around the Milky Way galaxy. We just assume that frame of reference. So now as a little quick check, this is a short little video clip. You guys ever see Sesame Street when you're a kid? One of these is not alike, okay? So this one you have to figure out, is a train moving? Is a lady moving? Woo, is a boat moving? Is a man moving? Okay, here we go.
Is the train moving or the platform? Motion is relative. What you perceive depends on your point of view. If you are standing on the river bank, it looks as though the barge is moving and the boatman is not. But if you are on the barge, it looks the other way around. Your view depends on where you are.